Oh, this is so exhausting, but it's so much fun. Ah, man. Day 6. Guard Gallivant. The historians use their fancy device again, this time to whisk you all the way to the North Pole prototype suit manufacturing lab in the year 1518. It turns out that having direct access to history is very convenient for a group of historians. I would imagine. You still have to be careful of time paradoxes, and so it will be important to avoid anyone from 1518 while the historians search for the chief. Unfortunately, a single guard is patrolling this part of the lab. Maybe you can work out where the guard will go ahead of time so that the historians can search safely. Make sense? You start by making a map, your puzzle input of the situation. For example, okay, we have a lot of periods, some pound signs, and then this little character. The map shows the current position of the guard with that character, okay. Guard is currently facing up, oh, I see, from the perspective of the map. Any obstructions, crates, desks, alchemical reactors, etc. are shown as a pound sign. Lab guards in 1518 follow a very strict patrol protocol which involves repeatedly following these steps. This is very convenient for us. If there is something directly in front of you, turn right 90 degrees. Cool. Otherwise, take a step forward. Okay, this all seems easy so far. Following the above protocol, the guard moves up several times until she reaches an obstacle, in this case a pile of failed suit prototypes. Okay, so she starts down here somewhere and she works her way all the way up and she hits this wall, so she stops. Because there is now an obstacle in front of the guard, she turns right before continuing straight in her new facing direction. That makes sense, she was here and then she went to the right, cool. Reaching another obstacle, a spool of several very long polymers, she turns right again and continues downward. Cool, this makes sense, so she goes here. This process continues for a while, but the guard eventually leaves the mapped area after walking past a tank of universal solvent. Okay, cute. By predicting the guard's route, you can determine which specific positions in the lab will be in the patrol path, including the guard's starting position. The positions visited by the guard before leaving the area are marked with an X. Okay, so she started down here, worked her way up, down, da-da-da. Yes, you can mark all of them with an X. In this example, the guard will visit 41 distinct positions on your map. Predict the path of the guard. How many distinct positions will the guard visit before leaving the mapped area? Cool. Okay. I'm going to go ahead and say something I might regret, but I think this might be somewhat easy. I have some experience doing like 2D game stuff with like grids like this and map layouts. So yeah, I think we can do this. So let's go ahead and get the example input. I'm going to go ahead and put this into my terminal. Let's pop open the terminal. Cool. So let's double check where we are. Cool, we are in day 6. This is perfect. Example input.text. Put that here. Awesome. And then I'm going to go over and grab the real input. Okay, and the share is back on. So what we have to do is we have to read in this data, create some sort of 2D grid, and we're going to go through it, and we're going to be this person who's facing upwards. Now my question is, in the real input, will she also be facing up, or could she be facing a different direction? I'm going to look for this real quick by just looking for this character in my real input. Yes, okay, so she will be facing upwards there. So the guard is facing up to begin with. That's nice. I don't have to worry about like a greater than, less than, and a down facing arrow. Okay, cool. We are good. So we'll call this part 1. I'm not going to try and be clever with the names anymore. We are just going to name these scripts exactly what they are. So we have part 1. That is all we will call it. Let's vim that file. Let's take a look at what we got here. And we are going to read in this puzzle, and we want to read it into a 2-dimensional array. We don't have 2-dimensional arrays, so we have to fake it with an associative array, and we will just call it grid. So while read -r line do done echo line. This should just read the file line by line. So let's go ahead and test this by reading it from example input, and we get that. That's exactly what we wanted. We are reading the file line by line. So now that we are reading it line by line, we also need to read it character by character. So let's call this, instead of line, we will call this a row, and we will make it an array. Perfect. That makes sense. We will also need to calculate the the width and the height. So let's do that here. Let's say width equals 0, height equals 0. And then we will calculate it. So let's do this one thing at a time. Let's worry about width and height later. Let's just save these to the grid. So we are reading through the row, and our current row is, how should we keep track of this? We should probably have a y coordinate and a, yeah, let's trash these for now. Let's have a y coordinate and an x coordinate, right? Okay, so every time we read a row, when we're done reading that row, we will increment the y coordinate because we will move down to the next row. And then we will do a for x equals 0, x less than width x plus plus. Cool. Now we have to actually calculate the width. So let's do width equals the length of the row. This should never change. Every row should have the same width. So we can just technically do it each iteration. It's kind of redundant, but that's okay here. So we'll get the length of the row. So now we have a width. So what do we have here? We have the width. We have this y plus plus. And then when we get to the bottom, we can say height equals y. Okay, now we will have the height and the width when we are done with this. We don't need this. Okay, so in here, we can say, let's just echo this out. Let's do x comma y equals whatever character is there. And the character C will be what is at row at spot X. It's a little bit confusing, but when we print this out, I think this will be easier to understand. So we'll say at coordinate X and Y, it equals to character. Not even close to right. What did we do wrong here? I'm going to be just indexing something slightly wrong here, but that's okay. Let's do echo width equals width, and let's see what we got going on here. Okay, so we think it's a width of 1. Why is that? Oh, we've run into this before. It's because I'm trying to break them on something in the IFS, and there actually is nothing to break them on. So instead of reading them into an array, we'll just keep reading them into a string. That's fine, but we will just index the string at that spot. And the way we do that is we don't access it like an array. We access it at spot X, and we want one character. So we're going to do a substring notation here. So row stopped being an array. Row is a string, but that's okay because we can get the length of the string, and that's the width, and then we can get the character there. So if this all worked out, then it's still broken. Awesome. Okay, let's figure out why we are broken. Let's just do this too. Width equals width, height equals height, and let's make sure we know what's going on here. Width equals 1 and height equals 10. Okay, well that's incorrect. Oh, because I'm using array notation there. That doesn't make sense. This notation allows you to get the length of a string, not an array. So, okay, that looks better. Width of 10, height of 10, is that correct? 1, 2, okay, we have 10 lines. 1, 2, 3, 4, 5, 1, 2, 3. Okay, it's 10 by 10. So that's good. That is correct. Now we will just do some spot checking here. So if we look at coordinate 4, 6, that's X, Y, we should find the guard. So if we're on the X coordinate, 1, 2, 3, 4, so this is 4 over from the left, and we move down 6, we should get here. Is that right? That is right. Oh, you know why? Because it's at a 0 index, and so it's the 7th line is where array spot 6 would be, because it goes to 9 and not 10. Okay, this actually makes sense. We are getting somewhere, which is crazy. That's awesome. So what we should do is we should find out the X and Y coordinate of the guard while we're doing this. While we're going through and we're calculating all this, we should figure out where the guard currently is too. So what we'll do is we'll do guard X equals -1, guard Y equals -1, and then if C equals this character, which is the guard character, then we know that we have found the guard. And then we will do guard x equals x, guard y equals y. If we wanted to be pedantic here, we could do some checks. We could make sure that these variables are -1 before we set them. We could make sure that down here that we definitely did find the guard. I think we can assume that our input is correct, but let's go ahead and just be good here. Let's say if guard x equal -1 or guard y equal -1, then echo, could not find guard in input. I don't think this is necessary. I think we can assume the puzzle is valid, but let's just go ahead and be good. Make sure we found the guard. Let's go ahead and comment some of this stuff. Read in the data and save it into the grid. Also find out where the guard is. Cool. I like that better. Cool. So now, if this is correctly, or if this is done correctly, we should have puzzle width, puzzle height. Guard location equals guard x, guard y. Let's go ahead and run this. And cool, guard location is 4,6. Hey, that seems really, really nice. So now we know where the guard is. We know that the guard's initial direction is up. I think it's always up. Print what we have so far. Guard always starts by moving up first. Okay. So, what are we going to do now? We have the puzzle in this thing called grid. I'm trying to think if we have a nice way of printing out grid, if that's worth it. If I should write a function to take this associative array and print it out. We probably should. Yeah, we should probably have a function that does that. So let's go ahead. We're going to use width and height in that function. Yeah, so let's go ahead and make a nice little function called... whoops, that's not even right. We'll do print grid. So this function will print the current grid out in a nice, easy to read fashion. So we will do for y equals 0, y less than height, y plus plus. Do for x equals 0, x less than width, x plus plus. Do done, done. Local y, x, so we don't bleed into the global scope. Although I don't know if you define them inside a for loop, if they do or not. I should probably double check that. So what do we have here now? We need to grab the character from that. So local c equals grid x comma y echo dash n c and then echo here, and that should print the grid. So if that's all correct, then we can do print grid down here, and the last thing it should do is reprint the grid. It printed nothing. So that didn't quite work. I'm gonna go ahead and get rid of the echoes here because this isn't useful. That's just creating a lot of output. So the output will now look like this. And you can see I would like it to print something here, but it looks like C is always set to nothing. Why is that set to nothing? Let me try this. Local key equals x comma y, and then we will just do key grid. Still doesn't work. Now, why might that be? Did I remove the part where I was saving it in the grid? I think I did. You never set grid. Yep, yeah, I just noticed that too. Yeah, I went through and did all this nice little work. I found the guard, but I never actually set the grid, so that's really funny. So let's do key equals x comma y, grid, key equals c. There we go. Now we save the grid. Hey, look at that. Now, does that look like our original input? It does look like our original input. That's beautiful. The benefit to this is that now we have a really nice way to print the grid. So when we're doing work, we can do really quick debugging by being able to print the grid and make sure everything makes sense. So let's go ahead and step through it. So we're going to constantly step while she is still in the map. So while she is still in the map, we don't know what that condition is going to look like yet. So let's just say while true. We'll do it in a while true loop, and then we'll break out when we need to, and we'll come back and revisit this conditional and figure out exactly what needs to be done. So while true, try to move the guard and see what happens. So the way I want to move the guard is we're going to have a new X and a new Y. What that means is we're going to try to see what it would look like if we move her in that direction. Then we're going to check that spot in the map. And if it's valid, we'll commit to moving there. If it's invalid, then we'll figure out our course of action. It's only going to be invalid if we hit a pound sign or we walk our way out of the map. So let's go ahead and do this. Imagine what it would look like if we move her. Okay. So now we check if new X is, we have to check if it's inbounds now. If new X is less than 0, or, sorry, is it or? It is or, yeah. New X is greater than or equal to width, or new Y is less than 0, or new Y is greater than or equal to height, then echo she left, LOL, and we can break out of this loop. Cool. So there's our bounds checking right there. So what we can do now, this loop will just run forever because we're actually not doing any work. Check her bounds. Check for collision, I imagine. Figure out how to move her based on her direction. Cool. So we'll do a nice little case statement over her direction because it's going to be a string that has 4 different possibilities. It's basically an enum if this was a different language. Case direction in up, down, left, right, and then this will never happen. We could put error checking there. I'm not even going to bother. So if we're trying to move her up, then we want the Y to go down. Might sound confusing, but we're starting with Y equals 0, and then as the number gets higher, we're moving down. So if the number gets lower, we're moving up. So new Y minus minus. New, if we're going down, then new Y plus plus. If we're going left, then new X minus minus. And if we're going right, then new X plus plus. That seems very simple. So the next thing we do is we check our bounds. Let me put this down here so I don't forget. If we are here, she has walked out of bounds. Cool. So now we check our bounds. That's cool. Now we need to check for collision. If, let's get the character at that spot. So new C equals grid at new X. Let's just do it this way. Key equals new X, comma, new Y. Key. Now we will check what this is. So let me think about this. I think we can do a nice little case statement here. If it's a period, then we are free to move here. And the way we will do this is we will set that spot in the grid to be her and the last spot that she was to be a period. We're going to swap them. Okay, that's easy enough. Let me think about all the possible cases here. The other possibility is that it's a pound sign. And if it's a pound sign, then we have a collision. And the only other thing she could run into would be nothing. We've already checked the bounds, and she's not going to run into anything else. So let's make our life a little bit easier. We're just going to make a fatal function. Echo whatever arguments they gave us, send them to standard error, and let's exit here with 1. That way we can just simply call fatal. And we can kind of just add error checking. There we go. We get nice little error checking for free. That way we can do something nice here. Unknown grid char new C. And we're done. Okay. Cool. Almost there. If we hit a period, then we are free to move here. So what we do then is we will say grid new X, new Y. This is where we're going to move her, equals her. So this is our guard. And grid X, comma, Y, this was the previous position that was her, is now going to be a dot. So we're basically swapping her in them, and we're leaving everything else the same. I don't think there's anything else we need to do except set X equal to new X and Y equal to new Y. Cool. That's how we will handle moving her. So now we need to handle a collision. So if there is a collision, we need to move her direction. Okay. So we need to do case direction. Let me think about this. Case direction in, so let's handle all the possible directions. I already have them here. So she needs to move 90 degrees to the right. So we just have to calculate that here. We have a collision. Turn her. So if she was going up, she is now going right. If she was going down, she was now going left. If she was going left, she is now going up. And process of elimination, if she was going right, she is now going down. Cool. So we've effectively turned her. And now that we've turned her, there's nothing else we need to do. We just need to move on to the next iteration, right? Yeah, all we've done is turn her. Because then we will just check again. I think this is it. Now, we don't have any sort of logic to test how many moves it takes or whatever, but we can add that. So let's go ahead and print grid, I think I called it. Yeah, I called it print grid. And then what we'll do is we'll put a read command here. Now this will block until I give it some sort of input. Let's say read-n1. This will block until I give it any sort of character. No, let's just leave it as read. I'll hit enter. This will block until I hit enter. So we can hit enter and kind of watch her walk around. So that should work. Part 1, read in from example input. Unknown grid char. That. Okay, where do we have that? Oh, we found her character, right? Well, no, we shouldn't have found her. Did I put this anywhere else? Grid char. Does that only appear in one spot? That does. Why did we find her at the new C and the new R? Why did that happen? Because in Bash, we don't fall through. Case statements don't fall through in Bash. So I don't have to worry about any sort of weirdness with that. Why did that happen? Okay. We moved her up and well, it's definitely wrong that we have her moving up, but it's definitely wrong that it's printing twice. All right, let's figure out why that is. Okay, so the first thing we got is move her. That's great. So we moved her. It seems like something here didn't quite work the right way it should have. Oh, I know exactly what's going on here. I just used the variables x and y. Those don't exist. They were guard x and guard y. And they were guard x and guard y. Oh, there we go. Oh, wow. Okay. Cool. So a lot of stuff happened there, and it looks like the read command didn't quite do what I wanted it to do. It shouldn't have blocked. Am I crazy? That should have blocked, right? Yeah, it blocks until I hit enter. Why didn't that work? Oh, because I read the puzzle from standard in, so it didn't actually block because standard in was already closed at that point. All right, so read would have just failed. So let's try this. We're going to try something crazy. Let me think about how I want to do this. We'll sleep 1, we'll clear, and then we'll print the grid. Let's go ahead and make this sleep a 0.3 so we don't get bored. And we're going to watch this animation. This is working. Look at that. She's moving down. Now she's moving left. Now she's going to move up. Now she's going to move right. Now she's going to move down. Hey, this is working. Now she's moving left. Now she's moving up. Now she's moving to the right. And she's going to walk off screen. There we go. This works. How awesome is that? What a beautiful little animation that plays. Oh, boy. That is super fun. I think there was a little bit of flashing there. We can probably get rid of that by generating the grid first, like display equals this, because I think it takes time to generate the grid, and then after we clear it we can echo display, and then we'll get rid of that whole like stuttering that we were seeing. There we go. That looks a lot cleaner, doesn't it? Perfect. Perfect. Nice. T put civvies. Yeah, doesn't that just make my cursor invisible? Yeah, I think they'll just make my cursor invisible. There's a whole bunch of stuff I could do. I could do, was it tput sm cup? So I could go to the alternate screen and then tput rm cup when I'm done. I'm not too worried about making this super nice at this point, but it is cool to watch her move around. So now that we have her moving around and it works, we need to actually gather some metrics. So let's figure out what metrics we need to get. We need to figure out the distinct positions on the map that she went. So this is another place for an associative array. We'll make an associative array and we'll keep track of places seen. So declare -a places, or we'll just call it seen. Let's see. Let me look at chat real quick. Are you going to rotate the arrow? I could. I have no real desire to do that. Also, what would I use to symbolize a down arrow? I have no real desire to do that. Honestly, I'd probably just make her something else if I wanted to. I could just make her like a G for guard or something. But I totally could. Let's get rid of turn her. Let's get rid of move her. What do we have? We have seen. So every time she sees a new location, meaning every time we move her, we will keep track of it. So seen, guard X, guard Y equals, we'll just set it equal to like true. That'll just be literally the string true. And then we have to keep track of the first location we've seen her in, because she always starts in the spot that she starts. That counts as a unique spot. So now, every time we do this, at the end, we can check how many items were in scene. So I think we can just do this. Distinct equals scene. And then we just put this pound sign in front of it, and that will get that echo visited, distinct positions. I think we should just be able to do this. Let me look at the chat. V, oh my god, you guys are right. We could just use V as a down arrow. We could, do you want me to do the guard character? Would that be cute for you guys? Would you guys want that? Because we could do that if that's what you guys want. Let's see, how would we do that? We'd have to come up with what the guard char is here. So, case, direction, in, up, guard char is this, down, left, right, down is a V, left is this, right is that, ESAC. We'll set this new one to guard char. There you go. Is everyone happy? We'll see if this works. So. Hey, look at that. Look at that. That is beautiful. There's one little thing that's annoying me. When we switch her direction, when there's a collision, we do switch her direction, but we don't actually reset her character to technically look the other way. So we could literally just do this. I'm copying and pasting code, but here we are. That's not where that goes. Why is ESAC in there like 8,000 times? I think this will work. So now we'll see a moment where she switches direction. Oh, she's... Oh no, she's propagating. She's becoming... Okay, this is a bug, but it's actually really cool because you can see the direction she started moving because of the collision. So, like, it's a bug, but that looks really cool. I actually really like that. I have to say, that's pretty neat. Yeah, because we don't want to update that. We want to update this and this. Okay. Oh my God. Oh boy. What am I doing wrong here? Oh, I did Y and Y. Yep. She leaves a log. Yeah, exactly. She writes down what direction she went. Hey, this looks really good, doesn't it? Look at this. I love it. We will have to speed up the animation for the real input because I think it's going to be gigantic. But visited 41 distinct position. Look at that. Let's make it plural. That way, if the answer is ever 1, it still is grammatically incorrect. So 41 distinct positions. If we pull back open the web browser, we can see that she was supposed to hit 41 distinct positions. So that's beautiful. Now we can go through, give it the real input, and we should be able to calculate that. So I just want to see. Okay. This might be fun to visualize later when my terminal isn't so stretched out. Do I want to do that right now? It would be kind of fun. Hold on. What did I call it? Is it 2024? Advent of Code? Day 6. Part 1. Read in from real. Oh, it's too tall. Oh, but I can see her moving. Oh, that's so funny. Oh, it's too tall. That's okay. We won't do the visualization here. We'll just get rid of this visualizer. That'll be fun to do. It'll be really fun. I'll probably go through and make some sort of fun visualizer for this, but yeah, let's just go through and run the calculation. What we can do is we could echo a dot so we can keep track of our progress. So that'll be kind of fun. Actually, yeah, we'll just echo a dot. We'll echo a dot, and then we'll echo here when we're done. So let's do this. Let's do this. Visited 4433 distinct positions. You want a counter? Let's do a counter. You know what? I'll give you guys a counter. Let's do this. Let's do counter equals 0. Not needed for the puzzle. Just fun. And then we'll do a nice little counter plus plus. Cool. And then what we can do is we can printf We could printf the counter. What should we do? Maybe like 04D. Let's just do 5D dot 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 \r the counter. So now let's do a tiny little sleep, just so it doesn't go super fast, and let's see. That's pretty cool. I have to say, this is pretty cool to see like this, because I think it goes up to 4,000, right? This is fun. It makes it look like we're really calculating something tough, even though Bash is way faster than this. There we go. Oh, it overwrote and it said she left. But yeah, so it looks like she made like 4,800 moves and 4,433 were distinct of that. That's pretty cool. This is pretty cool. Let's see. Nick, hey man, binging your videos lately? Yo, thank you. I appreciate that. My YouTube growth has actually started to pick up a little bit, and I'm super excited for that. My goal was to hit 15,000 subscribers by the end of the year. I think I'm going to hit that by the end of the week, which is, only a couple weeks away from the end of the year. But still, that's really cool. So let's go ahead. I think I have the answer here. Let's try and plug it in over here. That's the right answer. You are 1 gold star closer to finding the chief historian. Beautiful. We did it, everyone. Part 2. While the historians begin working around the guards' patrol route, you borrow their fancy device and step outside the lab. From the safety of a supply closet, you time travel through the last few months and record the nightly status of the lab's guard post on the walls of the closet. Returning after what seems like only a few seconds to the historians, oh, this is cute, they explain the guards' patrol area is simply too large for them to safely search the lab without getting caught. Fortunately, they are pretty sure that adding a single new obstruction won't cause a time paradox. Oh, God. Oh, please don't know where this is going. They'd like to place the new obstruction in such a way that the guard will get stuck in a loop. Oh, that's neat. Making the rest of the lab safe to search. To have the lowest chance of creating a time paradox, the historians would like to know all of the possible positions for such an obstruction. The new obstruction can't be placed at the guard starting position. The guard is there right now and would notice. In the above example, there are only 6 different positions where a new obstruction would cause the guard to get stuck in a loop. Holy God. Oh boy. The diagram of these 6 positions use O to mark the new obstruction, pipe to show a position where the guard moves up down, hyphen to show a position where the guard moves left right, and plus to show a position where the guard moves both up down left right. Option 1, putting a printing press next to the guard starting position. Okay, so oh yeah, you're right. Okay, so that would cause a loop. Option 2, put a stack of whatevers in the bottom right quadrant of the map area. Oh my God, yeah. Oh, and then they walk into that loop. Okay, I see. Option 3, put a creative whatevers. Okay, so they go up here, they go here, they go here, and then they get stuck in this loop. Doesn't really matter what you choose to use an obstacle so long as you and the historians can put it into position without the guard noticing. The important thing is having enough options that you can find one that minimizes the time paradox, and in this example there are 6 different positions you could choose. You need to get the guard stuck in a loop by adding a single new obstruction. How many different positions could you choose for this obstruction? Oh my God. I have no idea how I'm going to do this. No one give me solutions, but I think I'm going to probably end up brute forcing this. But please, no one give me suggestions. But my God, what a day 2, or what a part 2. Run, all I did was CP part 1 to part 2. Run part 2 on the example input. Okay. Let's go ahead. Let's go back to visualizing this because that was actually super useful. We don't need the visualizer anymore. I'm editing part 1, aren't I? Yeah, I am. Let's just CP over it again. Okay, part 2. Okay. This is easy enough to follow. 0.3 is a little bit slow. Let's just do like 0.05. This will go pretty fast. Cool. That's fun to watch. That is really fun to watch. I like the visual aspect of this. It's easy. Just test to see if you're in a loop by solving the halting problem. That's literally the first thing I thought of when I was reading it. I was like, oh, so let me just solve the halting problem. Let me just solve like the hardest problem in computer science. Yeah, let me just do that real quick. Oh man, that's just so funny. All right, so we have to figure out where to put an obstacle that would cause a loop. I actually don't even know how you would. I don't even know how you would come up with an algorithm to say, give me all the places where a loop could be constructed. I'm trying to think of this. You'd have to like unravel this two-dimensional array into some one-dimensional representation and then figure out if something stops going out of bounds. That's very amorphous, what I just mentioned. There's got to be some way. There's got to be like some mathematical proof for this, but I'm thinking brute force might be the answer. Oh, man. Okay, I'm going to do it. Debug equals false. While getOps, we'll do D for debug. Opt do, case opt in, D for debug. Debug equals true. Fatal. All right, we'll just do an exit one if you give it something bad. ESAC, done. There we go. Now we have argument parsing. So now, if debug, then there we go. There we go, done. So now, make this easier for myself, I'm going to cat it and pipe it into part 2. That way I can just tack on the dash D and remove the dash D when I don't want it. So this should just be real fast. Yep. And then this will actually give me the visualizer. Yeah, what we need here is we need some sort of loop detection algorithm. And the loop detection algorithm would simply be like, she never gets out of her bounds. But how long do we run the simulation before we determine that she never gets out? So I'm trying to think of like how many paths she could possibly take. I think I'm approaching this the wrong way. Instead of trying to figure out if she never gets out, I think we might actually have to detect if she's in a loop. Now, how would you detect if she's in a loop? I think the easiest way to detect if someone is in a loop is if you are visiting the same spot. So if you've already seen this spot and you're moving in the same direction, if you're at a spot that you've already seen and you're moving in the same direction, you will be in a loop. Guaranteed. Has to be. So where we keep track of seen, we keep track of it with the Boolean variable true. We should instead keep track of her direction. This will be her direction when she has seen it. And then we can do a check here. If that already exists and is the same direction, then we know that she's in a loop. Here's the tough part, though. If she sees the same place and she's not moving in that direction. Let's leave this. Let's leave it because we still need to know. Oh, we don't wait. No. We don't need to know how many. Oh, I have an idea. That's my idea. We will keep track of the X, Y, and direction. So it's basically a tuple of these three things, the X, Y, and direction, and then we'll keep track of if we have seen this. So what we can do is we can say if -n seen key. If we have seen this, then we know that she is in a loop. Then echo loop detected. We need to break out of this, right? Let's worry about that later. Loop detected. Otherwise, we set the key and we move on. So we'll probably have to move this into a function, and that's okay. I think the way we should test this is put her in a loop. So I'm going to go ahead and modify the example input and manually put her in a loop. And the way I'm going to do this is I'm actually just going to look at the example over here and just copy one of them. So the way that they have put her in a loop is by putting a thing here. So this one next to her shouldn't exist, but this will put her in a loop. So if this works, she should detect it. Loop detected. Cool. Our loop detection logic is working. That's really good. No, don't delete it. Okay. So our loop detection logic is working. So now we can detect if she's in a loop or if she's able to walk out of it. We want to detect a loop. We care about loops. So let's put this here. Number of loops we found, because loops are good. That's the thing that we want. We want to find how many things will result in a loop. So we'll put a counter there, and every time we detect a loop, we will increment loops. And then what do? We break out of this loop. Okay. I have an idea. It's gonna be a little gross. Let's move all of that logic into run simulation. That's what we're gonna do. So we're gonna take all of this logic here, and we're gonna put it in run simulation. And we will clean it up. I might leak some variables here. I'm not going to worry about that right now. There's going to be some unclean code. That's fine. So run simulation, what this will do is it will set her direction. Don't even bother printing the grid. I don't care about that. We have seen where she is. I don't even think we need to count this anymore, to be honest. Oh no, we do need seen. Sorry, we don't need, that's what we need. Get rid of the counter. Number of loops we found. No. We want to return. Here's what we want to do. We're going to return 1 if she leaves, 0 if this loops. Because those are the only 2 possible cases. When we run a simulation, either she'll leave or we'll loop. So if she leaves, then we return 1. And if she loops, then we return 0. Okay. That is great. So now we have the ability to run this. We don't care how many places she's been. So now let's go ahead and run this and make sure it works how we expect it to. Okay. If run simulation, then there was a loop, num loops plus plus, num loops equal 0. So that's how many loops we've encountered. So the simulation is only going to run once. Okay, now I think what we need to do. Yeah, I was going to brute force the entire puzzle by putting an obstacle literally at every single possible thing. I think that's going to take too long. Because if the puzzle's 10 by 10, suddenly we're taking 100 times longer to run this whole thing. We have to test that many. So I think we're going to have to... Let's try that and let's see how slow it is. For y equals 0, y is less than height, y plus plus, do. For x equals 0, x is less than width, x plus plus, do. Done. Num loops going out of here. Then we need to run a simulation. So the way we're going to do this is we're going to add an obstacle here. So we're going to see in the grid, we'll take the original character out of the grid, like this. Take the original character out of the grid. If we can only change a period. So if orig equal period, then we will set grid x, y equal to this. This is our own obstacle. We are going to add an obstacle here, and then we are going to run the simulation. And then regardless of how that simulation works, we are going to reset that back to a period, and we're going to run phi here. This is extraordinarily brute force. Extraordinarily brute force, LOL. So we're going to go through every single possible puzzle. Echo testing puzzle x comma y. So let's do this. Total puzzles equals width times height. Current puzzle equals x times y. Testing puzzle, current puzzle out of total puzzles. We'll get an idea of how long this will possibly take. But this logic should work. It just might be incredibly slow. Let me double check here. Let's see what's going on. Width times height. That's the total number of puzzles there are. For y equals 0, y equals height. Hey, look at that. Let's be smart here. X equals 0, x minus or less than width, x plus plus. Current puzzle is these multiplied together. Testing puzzle, current out of total. Get their character from the grid. Check if it's a period. If it's a period, we set it equal to a pound sign. Then we run the simulation. If it returns successfully, that means there was a loop. And then we set it back and we try again. This should work, but oh my God, is it going to be slow? But let's run it. Something broke. Oh, I know what's happening. Yep. That was cool to watch, but I think I'm overwriting guard X and guard Y and not resetting them to all of the defaults. So what we should do here is, where do we get guard Y and guard X? Okay. Original guard Y equals guard Y. Original guard X equals guard X. There we go. And then when we run a new simulation, we should reset these variables. This could be guard underbar. This could be guard direction too, because that might even be simpler to understand. But for now, original guard X. Okay, I think that's better. So let's go. This is fun to watch. Okay, and I can see it adds a new thing. Unknown grid character V. Oh, you know what? When she leaves, I don't know if we reset the grid. So we should probably do that. Let me double check here. Oh, you know what it is? Yeah, it's because we're using all these directional things. And then I think we're leaving them in. We'll have to check. We'll have to check. Let me remember how to do this. Where does she leave? I think I put like left LOL, right? Yeah, she left LOL. Why don't we just do this? Why don't we just... How do you copy... Can you copy an entire array in Bash? Or do I have to do it key for key and like really... Oh, I might have to do that. Yeah, because I would like to start with the like original grid. You know what I mean? Hopefully that makes sense. I don't think you can just copy an associative array to an associative array. There might be a... Oh my God, I know a way. I know a way. Let me do some testing. I think I already have array, right? Yeah, I already have that defined. I think using parameter transformation, I think we can do this. What is it? It's like this. I think you do this syntax. Is it K? Capital K? I'll have to probably pull up the Bashman page. There is a way to get it. There's a way to get it to give me a declare statement. Is it just, yeah, I think it's dash capital A. A. There we go. I think I can do this. And then I think this is going to sound so stupid. I think you can actually just like eval this back in. There's gotta be a way to do this better. I can do it the simple way. Like I can absolutely do it the simple way. Here's what we'll do. We'll do it the simple way. I'm not going to make this more difficult than it needs to be. Where do we declare the grid? We'll also declare original grid. There we go. So now what we can do when we read it in for the first time, we can store it in both. Let's make a function called reset grid. So what we'll do here is we will unset grid, declare -a grid. I think we need G for global. I think we can do it this way. This will reset it to nothing. And then we can do for key in original grid. This is gnarly. There's got to be a cleaner way to do this, but I don't care right now. Value equals original grid key. And then we can do grid key equals value. So we'll just have a function called reset grid, and we can run it here. That'll work. Let's go ahead and run the simulation and see if that works. Basically, every time we finish, we're just going to overwrite that variable that we've been using with the original variable that we have stored. That looks way better. I don't see the obstacle moving. Okay. So let's do some cleanup here. Yeah, x times y. Oh yeah, that won't work. Right. Yeah, you're right. Because what I want is something other than what I have right here. I don't know. I want some sort of unique index. What am I doing? What am I doing, guys? Current puzzle equals 0. There we go. Current puzzle plus. What am I doing? What am I doing here? Oh my god. I can just do it this way. Yes, column plus row times line. You're right. That is what I'm trying. That's what I was trying to do, but I can just count them. Let's pipe it to part 2, debug. I don't love that we lose track of the testing puzzle thing because we clear the screen every time. That is annoying. Let's just sleep 1. Now where's the pound sign go? I don't see the new pound sign. Did we add the new pound sign? I don't think we did, right? Yeah. Okay. I got it here. Run simulation. Run simulation resets the grid. We don't want to do that. We want to reset the grid here. And then we want to set grid x, comma, y to... oh no, we already do it. We already do it here. So we need to reset it here because we were resetting it inside the function. Yep. This is what we want. Okay, reset the grid and then set that one. Okay, we were just doing things in a weird order. That's fine. Cool, now we see the pound sign at the top left. And when this simulation's done, the pound sign should move. There we go. Awesome. Yep, so this is brute force. We're going to test everything. Let's get rid of the sleep. We're not going to debug. Let's get rid of the sleep here. Let's see what this looks like. Okay, so 5 of them created a loop. Okay, so if we pull this back open, what should we have gotten here? There are 6 different positions where a new obstruction could cause the guard to get stuck in a loop. And we came up with 5. So something's not right. Why are we off by 1? That is the programmer's plight indeed. Okay. No loop, no loop, no loop. Why does this one not even print anything? How do we break out of that one without printing anything? How is that happening? We have loop, and we have... run simulations in a while loop. And we don't even have any sort of break statement, so it has to return out of it. Return run or we return 0. That's the only way we can possibly get out of there. Okay. I'm going to make this puzzle 1, so that makes more sense. We'll actually count up to 100. Oh, yeah. We print that we're testing the puzzle, but then there's already either she's standing there or an obstacle standing there, so we throw it out. Yeah. Cool. This is a lot easier to read. Cool, so we have a loop. Yeah, loop, 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 loop. Yeah, we got 5 loops. Okay. Y caused the loop. All right, so we can see which ones caused the loop. 3, 6, 6, 7, 7, 7, 1, 8, 3, 8. Oh boy, this is gonna be a nightmare to go through. Yeah, because I have to reference this with the original puzzle. Let me double check some things. Is my example input correct? Yeah, I think I turned it back to correct. Yes. I'd have to correlate these with 3 and 6, that one caused the loop, awesome. 6 and 7, that one caused the loop. 7 and 7 caused the loop. Oh, this is just going in perfect order. 1 and 8 caused the loop, awesome. 3 and 8 caused the loop. I'm missing a loop. There was a loop caused at 7 and 9, it looks like. 7, 9 should cause a loop. Oh, I don't... I should probably print that out regardless. It's going to be something. This is one of those things that's going to be something stupid. It says it's not trying this one. Why is it not trying? Hey. A V shouldn't be in there. How did a V get in there? How did that happen? I wonder if my logic to copy over the grid is incorrect. Because how did a V get written there and not overwritten? Yeah, because a V is my own thing. So she shouldn't have been able to go there then. Here's what we'll do. CP example input to modify.text. And then I will turn this into the puzzle that should fail. So this is the puzzle that should fail and is not for me. And we're going to run it through part 1. Oh my god. I don't have all day. Come on. No. Okay, so that has a loop. Yeah, so that correctly loops. But for some reason, we don't even bother trying this one. Because it thinks there's a V character. I'm so curious about... Wait. No, this should when you declare it here, it should overwrite any other one that was already written there. So I'm not relying on any sort of global state to do this. Yeah, this variable is not being used anywhere. Yeah, because like this one, that's just stupid. It should not be finding that character. It should not be finding that character in a puzzle before it decides to not do it. Because where it decides to not do it is if it equals a dot, then it tries to do it. It should not be finding it there if I haven't reset the grid. I haven't reset the grid. I haven't reset the grid. I'm so stupid. Oh my god. Oh my goodness. I should reset it here. That's all it is. I'm gonna get total loop 6 now. I told you. I know I said it, but I knew it was gonna be stupid. I knew it was gonna be stupid. I knew it was gonna be so dumb. Wow. Oh boy. Okay. Okay. Nice. We're getting 6. We're supposed to get 6. Let's go through and make sure this looks good. Cool. I'm just getting rid of some of the debug stuff. Cool. Yeah. Yeah. So I think we're good to run this on the real input. I don't know how long this is going to take. I don't know if this is too much of a brute force and I might have to come up with a faster solution. Faster solution being only look at her path, calculate her path, and then go through and put the obstacles in front of her. Or just put the obstacles in all the places that she visits. Because I could literally do 2 passes. I could go through and see where she visits on the first pass, and then go through in the second pass and loop all of those and just test those. That's way faster, but let's see how slow this is. Here we go. All right. All right. We're 100 in out of 16,000 possibilities. We are 100 in of 16,000 possibilities. Bash is so fast. Here's what we're going to do. I'm going to rewrite this. I'm going to do 1 pass, find out her path, and then create a list of all the places that she's seen, and then we're going to loop over those and try to put the obstacle there and see what's happening. Thread it. Listen. Threading it might be a way to do this. I could... Yeah. Actually, wait, you're so right. Let me think about this. Because each one runs in its own function. counting it may be difficult because if you run different bash, I'd have to test this. If I put bash functions in an ampersand, can they modify a global counter? In most languages, just a simple counter is atomic. You are right that there were 4433 distinct places. So with that logic, it's still a lot. Like, we'd be 20% of the way there, but let it run and see if you can create a faster version before it finishes. That's fun. I like that. Use a file as your counter. Semaphores. It'll be quicker to let it run. Yeah, there's a lot of stuff going on here. Literally, I could just let it run. We could also use a file as a counter. That's totally correct. I think we could probably safely use a counter. I'll think about this. I'm going to let this run. I will be right back. I'm going to go grab something to drink from my fridge. All right, give me like 1 minute. I'll be back. All right, I'm back. Yeah, even if I cut it down to that original list, 4,000 is still a lot. Oh man. No, today we got Dr. Pepper, 0 sugar, 0 calories. If you follow me on Instagram, you may know that I've been dieting a little bit, been losing some weight, and I've been making really, really good progress. I'll give you guys a quick little story. In August, I was in the hospital. I'm not going to bore you with the whole story, but long story short, there was a whole bunch of weird health stuff going on and weird unknown stuff. Yada, yada, yada. All that stuff aside, I was still heavier than I wanted to be, higher blood pressure than I wanted to be, and just completely out of shape. So got myself one of these little smartwatches. Been doing 10K steps every single day since I was in the hospital. So August 22nd, I was in the hospital. Every single day since then, I've hit 10K steps at least. I do intense cardio 2 to 3 times a week, and I monitor my calorie intake. I started getting serious about it last month and a half. And I'm currently down from when I was in the hospital, I was 260 pounds. As of this morning, I was 241. So my goal is to get down to like 200, which would be relatively healthy for my height. So that's my goal. But I love soda, so at least I have the 0 sugar variant. Every single one writes out. Every single thread would have its own ID, which would be the number of the puzzle. It would write it out to a file, and then we just loop all those files and add it back in. Yeah. Sorry, I shouldn't laugh. My solution is similar to yours, but I got the wrong answer. I'm so sorry if that's the case, because my solution is going to take 8 years to run, and I would hate getting the wrong answer after all this. I don't think we're going to sit here and wait for it to go to 16,900. But what we can do, no, I need a little bit of break. Let's break out of this and let's put them in, a background task. How are we going to do this? I think what we need to do, I have to think about this, because there is some global variable stuff, but I think they get copied in at the time of forking it. So I think we can do this. Hear me out. We can do this. How do we keep track of how many background processes we have? I think we have to limit it to like, what are we going to do? Like 10 at a time, 20 at a time, X at a time. Capture the return codes. That is a way to do it. That is a really good way to do it. Because I could return one if there's a loop and we can just add them all up. We might be conflating errors with it, but we can burn that bridge when we get to it. I think everything gets copied when I do this. I think we're okay to do this. Let's make a function. Spawn task. Local ID equals $1. We'll just give it some things. The ID is the current puzzle, and the X and the Y that we're testing. We're just going to give it that. So, oh, this is going to print so many things out of order, but that's okay. We'll worry about that later. So we have a spawn task function. We can put parentheses here. This will create a brand new environment for it. So none of these variables should like bleed out or anything. I don't know what I think. I think they can just access the global grid. I think that will be copied over because of fork and exec. I think we're okay. So we will spawn task, and run simulation is the thing. Local loop equals false. If we are here, then loop equals true. We shouldn't need to reset anything because this should just die out. So let's return, actually, instead of just loop, we'll just say return code equals 0. If there was a loop, then we'll return code equals 1. And then I think we can just add the return codes together. But let's try this. Spawn task, put it in the background. This is going to be too many tasks to spawn. Let's try this. Let's just do this. Then we'll call wait immediately after and make sure we can do what we want here. So code equals $? If code equals 1, then num loops ++ fee. So we're echoing into a background task, but we're only doing one at a time, and we're going to do this against the example input. Okay. So every single one thought it was puzzle 1. And I think this is actually, I think there's a bash frequently asked question about this exact issue. Like this exact thing. Increment current puzzle. Oh. Okay, yeah, I'm stupid. What do y'all want from me? Thank you, though. And this should actually happen right before we spawn a new one. Let's set this to 0. Cool. Total loops is 0. So this wait did not exactly work how I wanted to. Can't wait get the exit code? Return the status of the last ID. Fails if the ID is invalid or an invalid alternative. I thought wait gives you the status code of the last one, right? Am I crazy? I really thought that was the case. Let me do some testing here. Echo returning ret. Let's just make sure that this logic works how I expect it. Yeah, so this one should be returning 1. And wait. Echo. Wait says code. Yeah, so wait is just not returning the code that this does, that I thought it would. Can I do this? What is the PID equals this? And I can do wait PID. There we go. That works. I have to specifically wait for the PID. That's less than ideal. That is absolutely less than ideal. And how are we're basically, there's probably an easier way to do this, but what we are doing now is basically like creating our own job and queue management system in Bash, which isn't the end of the world. It's just a lot. I'm putting one thing in the background and then waiting for it to finish. So it's not running any faster than the original solution. I need to put a whole bunch in the background and then append their PIDs to like a list. So let me do some checking on wait. Wait, I think, what did it say for a list of them? If n is supplied, waits for a single job from the list of IDs, or if no IDs are supplied, for the next job to complete and return its exit status. I think, yeah, what I don't understand is why do I not get the code if there's no ID specified? That seems problematic. Yeah, why do I not get the code? What I think I can do, though, I can do this. PIDs plus equal. So we'll add this to an array of PIDs, and then we can wait for all PIDs in that list, which will just be 1 in this example. So that works. Now we have to just append a whole bunch, and then we can do a wait here. If let's do this. Let's do this. If len equals PIDs, we'll get the length of how many pins we have stored up. If len is greater than 10, let's just do 10 at a time, then we will stop here and we will wait for one of them to finish. Any one of them, it doesn't matter which one we wait for. We will wait for one to finish, and then we will go on and we'll spawn another task, and we'll just keep going through this loop. Then when we break out of this loop, we will have to run this exact logic again to drain the rest of the PIDs that are there. So we'll have to say, we have to remove it from the array too. Oh, that sucks. How do you remove it when you're done? Oh, I know how to do it. I know how to do it very easily. This will be an associative array. Oh, yeah. Oh, yeah, we're on to something. We are on to something. The PID will go here because the PID will be some unique identifier, and we'll set this equal to anything because it's currently running. And then we will wait for all of the PIDs here. And then when any one of them finishes, we won't know which one it was. Yeah, how do you know which one it was? How do you know which one is finished? Oh my god. Okay, so we need a dash P argument. Dash N options while I wait for a single job from the list of IDs. Okay, okay. Wow, okay. Dash N, dash P, ID. Oh my god. Okay. Let's do this. This is going to be bad. Sorry, guys. This is way more scuff than I realized. Cool. Okay. So we should have the ID of the one that finished. Yes. Okay. This is going to sound weird. This code right here takes a list of PIDs. We give it a giant list of PIDs that we have outstanding. Dash N means only wait for one of them to finish. We don't have to wait for the whole list. Just any single one of those PIDs needs to finish executing. And then we store the PID in this variable called ID. So we get the exit code. We get the ID. Now that we have the ID, we can unset PID's ID. I think I need $. We will unset that. So now we take it out of the array. Okay. This is going to work. This is going to work. Oh my god, this is going to work. Drain the rest of the PIDs. So we need to go while there's still stuff in PIDs. So while PIDs. While PIDs is greater than 0, while there are still outstanding PIDs, we will wait on them and then we will get everything from them. So we're going to run the exact same code here. We could put this in a function, but for now I don't really care. Take this. There we go. Oof, that was a lot. Thank you for bearing with me. But if this is... Oh, I wrote wild then. Do. If this works how I think it should... Total loop 6. And we did 10 at a time there. Boy. This is wild, and we are abusing exit codes to transmit data. Oh boy, that's so funny. That is so funny what we're doing here. This is going to be just so much ridiculous output. So what I'm going to do here is we're going to get rid of some of these lines. So we're not flooding the output with stuff every time. Okay. And now we're going to find that thing where we say testing puzzle. We're going to get rid of the -n here. There we go. So now we just have this. So we'll at least know roughly what puzzles we're on. And this is going to run 10 at a time. We could probably do more, but let's start with 10 at a time. Wow, I had to write a whole little job management thing in Bash. How beautiful. Okay, that is significantly faster. That is significantly faster. Oh my god, like I would be okay letting this run. That's super neat. Yo, thank you, I appreciate it because oh my god, that took a lot of my skills to be able to do. If len is greater than 10, let's do this. Concurrency. This is how many threads will be used for concurrency. So let's make this, let's do 50. Let's do 50 at a time. There we go. Ha! Look at that. You can kind of see it batches up. Oh, wow. This is so much faster. I'm going to wait till I hear my computer start like kicking on the fans. Look, we're already at 1,000. Now, do you think we could push this much further? Should I stop it and try like a way higher concurrency? Or is this good enough? Just let this roll. I feel like we should just let this roll because we're already 2,000 out of 16. 1 out of 8. Not bad. It kind of seems maxed out. I agree. I'm okay with just letting this go. We're already about a quarter of the way there, so whew. Wow. So how's everyone doing tonight? Oh man. How many cores do you have? This shouldn't be a weight heavy task. Having more processed cores probably be counterproductive. It might be. It's true. How many cores do I have? I don't even know. This is running on an M1 Mac Studio, but it's like the M1 Ultra, I think. So like very beefy. Yeah, all the cores are maxed out. So yeah, it's being crushed right now. Man, Bash is not the right tool for the job. Although, was the top CPU OBS? Okay, the top on CPU is OBS right now. So I mean, like, whatever. That's frustrating. Listen, it's doing great, guys. We're almost halfway there. Look, we are 8,000 of the way there. Here we go. We're getting there. We're getting there. Only 500 left to check. I'm so scared. I'm so scared. 1516 is the final answer. You ready for this? We're going to see if this works. 15, 16. Let's go. Let's go. Oh my god. That's the right answer. You are 1 gold star closer to finding the chief historian. You have completed day 6. You can share this victory or return to your advent calendar. Oh, this is so exhausting, but it's so much fun. Ah, man. Let's go. Let's go. Thank you. Thank you, everyone. Oh, man. This is fun.